Save me. I'm being held hostage.
You are not being held hostage. We're doing a science project.
See, she's trying to.
Jordan!
Newton's first law of motion. The definition of Newton's first law of motion is an object in motion will stay in motion unless it is acted upon by another force. Like, not the Star Wars force. Well, I guess you can use the Star Wars force. I don't know. I listed some examples here at the bottom, such as brakes abruptly being stopped by a person. The person is driving. As soon as they hit the brakes, that's considered another force, which is causing them to stop. Another example is a baseball being thrown and the bat eventually hitting, a ball eventually hitting the ground. So the person at bat, the ball is going in motion. Eventually the person with the bat will hit it. Unless if they do hit a home run, it'll still hit the ground anyways, so that doesn't matter. As soon as the ball hits the ground, that's considered another force causing it to stop. So yeah, that's pretty much all I have for more examples. I do have an example here at the bottom. This ball is rolling on a table. It's eventually going to get to this point where it's in that form where it's about to fall off. As soon as it falls, it'll roll until it eventually stops, which is another force acting upon it, which causes it to stop.
Newton's second law. Apple. Okay? It states that force equals mass times acceleration, or capital F equals lowercase m times lowercase m. Some examples are, you're riding a bicycle. When you pedal, it brings up your acceleration because you're speedy, and your mass is yourself. Car. Another one is hitting the ball. There's a mass of the ball. I don't know if that's right, but you hit the ball, that's your acceleration because the ball goes flying. Throw the marker at you. Pushing a shopping cart. You take the cart and you push it, and you run it with it, and yeah, the acceleration is the shopping cart. I'm very good at explaining that. And then my example is car. So you got these two cars going down the street, and then they boom, run into each other, and then they dead. And they go and then they dead, and that's because the cars both are accelerating and they're heavy in mass, and then they go boom, and they dead.
I'm gonna break the brick with the force and the acceleration of my hand. Will successfully break the brick. Brick!
Newton's third law of motion. Every action has an equal opposite reaction. John Adams shot the bag, bumped the guy, the keys attraction. Poor Alexander Hamilton, he is missing in action, so now Thomas Jefferson is facing Aaron Burr with his own faction. Sorry, I just had to throw that in there. So, some examples of how this works is you're going on a diving board, you push down on the diving board so you can actually go off, and that's the action. The reaction is the board springing back up and vibrating. And then another one, you pull the trigger of, say, a Nerf gun, because this is a school video. The bullet shoots out. That's the action. The reaction is the force applied backwards pushes the gun back just a little bit, and that's the action reaction. Another one, car is going at the bug, and bug is going at the car. They smush together. One of them hitting them, whichever one happened first, is the action, and the other object hitting the one that hit first is the reaction. So that's it. Thank you.
Bye.
Peace out, physical science.